Hello, hello.
Hello. I think we are ready to start. Fatai, Luis, do you want to run the admin slides?
So can you hear me, Daniele?
Yeah, now of course. Yes.
Okay. So yeah, can go through the slides. The question was to me, Daniele, or for Fatai? I couldn't get it properly well.
Whoever is
For Fatai.
Okay.
Luis, I think you can. Yeah, you can run the slides. I didn't, download the slides from Daniele.
No worries. Okay, let's start. And maybe I can do that, Luisa. There is some background noise on your side.
Okay, I will try to fix anyway. I will move meanwhile to other quiet place. Sorry.
Okay, good. So let's start. Welcome, everyone. This is the second interim meeting of CCAMP. As we agreed, we did not meet at IETF 122 in Bangkok. We had an interim meeting before the IETF meeting, mostly focused on optical stuff, optical documents. Today we are planning to cover all the rest. So we have a microwave, we have OTN, but I've seen in the agenda also some surprises in our slots. So note well. Just a reminder for everyone that also the interim meetings fall under the IETF not well rules. I assume you are all familiar with this agenda. We have 7 slots today. We are going to talk about performance management. We are going to talk about autonomous networking level 4 scenarios and requirements. This comes from the TNF autonomous network framework. Export of gigabit passive optical network encapsulation mode in IP flow information in IPFix. This is, I think, this is not a CCAMP draft, but Thomas is presenting as it's relevant for CCAMP. This is an OPSA working group draft. Then we have a young data model for microwave radio links. This is a BIS that Scott will present to us. And then data model for fine-grained optical transport networks. And again, a data model for transport networks, RDNM, rich detail network management. Moving on. Just a small update from the last meeting. We concluded the second working group last call on RFC 1993 bis. If you correctly remember, during the last call of the optical impairment topology draft, some issues have been raised with impacts on 1993 bis. The authors have updated it, and we run a second working group last call, a short version, just 1 week. It was concluded yesterday or the day before yesterday, I don't remember. I'll be the shepherd for RFC 1993 bis. I already updated the write-up. Aomian will be the shepherd for the optical impairment topology. The optical impairment topology still needs to address some minor comments received from the working group last call. So the authors will issue version 18, and then we will move the two drafts together to the next stage as a cluster. Priorities, we try to keep the CCAMP wiki page up to date. This is what is shown as of today in the priority list. So in draft prioritization for working group last call, we can consider priority 1 items almost concluded. So the next one will be the WDM tunnel Young. Here we did a switch of prioritization. There was a push from the working group to prioritize the WDM pluggable modeling, and we will act accordingly. If I'm not mistaken, the authors said that the new version will be released in next week, if I correctly remember. And then we will run the adoption poll on that one. Just an heads up on liaison statements. We received 2 of them, not sent to us alone, but there is one from Etsy sent to CCAMP and PCE. It's the liaison reply to IETF on OCN, the optical cloud networks. This is as a reference to an individual draft. There is, I mean, it's referring to discussion on that one. There is also another one received from ITU, JCAMP 202 2020. It's a liaison on is an invitation to update the information, the IMT 2020 and the beyond roadmap. Any comments on our agenda bashing that you want to discuss? If not, we are ready to move to the first presentation. The presenter is Bin. I can give you the slide control.
Okay, no, can you control the my presentation?
Of course.
Okay, thank you. Okay.
Let me see if it works. Yes, it does. Please.
Okay, thank you. And so, hi, so this is Bin Yunus from Atri. And so today I'll present the update on the Young Data Model of Performance Management Streaming, version 1. And this document is to address performance management measurement methods and genetics PM parameters, and some example code, XML code of streaming subscription. Next slide. And the major change. This budget introduced the architectural changes by splitting the Young Data module, the PM streaming original, and into the 2 focused modules, the PM measurement and PM parameters for flexibility. And PM's measurement modules defines and the periodic measurement method, such as count, snapshot, tile mark, and notifications of a threshold event. And PM parameters module and defines the 3 parameter groups, classify the time interval to 50 minutes or the 24 hours, and their respective use cases, management and the service. I had some text, added some text and close for decoupling collections for analytics for the SPI, SPI is the target interface for the proposed young model. Next slide. And this slide is the visualized the transitions from the version 0 to the version 1. And version 0 and had this one single modules, the PM streaming, and version 1 split into 2 modules, PM measurement modules and PM parameter modules. And the next slide. Okay, and from this PM measurement perspective, version 1 had the containers of the PM measurement methods that was used 3 times for the PM 3 groups of PM parameter, and the version 1 use it 1 times because measurement methods can reference to the PM parameter. Let's go to the next slide. Okay, from this PM parameter perspective, and the version 1 incorporated this PM parameter groups, 3 PM parameter groups with the PM measurement methods, and within the single models PM streaming. And new versions created use modules called the PM parameter to contain the 3 types of different parameter modules: maintenance parameters with a 15 minutes interval, and maintenance parameters with 24 hours, and QS parameter with a time interval 24 hours. Let's go to the next slide. Okay, this slide showed how the proposed model is aligned with the IETF GDA 7710. And if you look at the figure and top left, the PM measurement method diagrams in GDA 7710 corresponds to the PM measurement modules, top right, and the PM parameter table in GDA 7710, bottom left, is mapped to the proposed PM parameter modules, bottoms right. The next slide. And basically, it's the proposed young modules intended to support PM measurement for SPI. And this it means that it is equivalent to more device model, not a network model. And the reason is that the GDA 7710 and the proposed young model is made based on recommends decoupling the data collections in the network element from the data analytics and management systems. And so NE is responsible for the real-time network monitoring only. So we did minimize network management methods with the count, snapshot, and timemark. And the analytic tasks, for examples, average variance, something like that, uploaded to the external management applications to enable the rich insight. And it can reduce computation burden and the memory overhead in the network element. Therefore, except for the 3 standard measurement method, is unreasonable to support numerous optional or vendor-specific methods with their needs. Next slide. Future one. these documents need to be aligned with the GDA 7710 for the PM streaming. GDA 7710 is being revised in IETF starting 15. The document will be consent on October 2025. And we'll add some use case and for the future version, and to harmonize with the existing topology models in IETF, and we update young data model. That's all. Thank you.
Thank you, Bing. Scott, please.
Yes, hi. Can you hear me all right?
Yes.
Perfect.
Okay, great. First off, I want to thank Daniela and others for organizing this interim. This is a great opportunity. And I also want to thank Ben for this fantastic work that he's doing. It's making something practical that has been in the works for a long time, but now we're seeing some fruit of that work, and I appreciate that. One question I have about it is, I like the split. Is there a way to augment the parameters container so that we can add other parameters to it and have the architecture work?
Mm-hmm. Your question is that how to manage this augmented over parameters, performance parameter.
Right, so that I can add
Yeah.
in like optical or
Yes.
microwave or something else, so that I don't have to change your draft, but I can still use your draft.
Yes, a good question. That is, I'm trying to adapt to this my model to the various type of use cases. That is why I try to add some use case for the future version of this document. It's a good question.
Right.
Thank you.
Yeah, well, and if you need help or want some support in exploring those, just let me know. This is a very interesting topic, and it's something that is aligned with work that's going on in ITU, and I think it'll be very useful for others. So I appreciate it. Thank you.
Thank you very much.
Hi, Bing.
Yeah.
Okay, this is Chowder.
Chowder.
And I just we have some discussion before this meeting, and we still have some question on the data model, and I found maybe we can further continue the discussion. But on the motivation of this draft, and I still have a concern, which is that as you mentioned in the slide, that this is applicable on the southbound of domain controller. Um, I quite I have a question. Currently, no, I don't hear anyone that have provided notification on the device and using IETF model. And I also have a question for you, that what is the advantage with your solution compared with telemetry and other notification mechanism? And I don't know whether we need this data model. Yeah.
Yes, that is the open issue. I think that primarily is by proposal is the focus on the based on the GDA 7710 recommendation. I know this document is very valuable for the vendors to follow this to catch up the minimum measurement methods, and yes, that is I think we need a collaboration together to position our model with the others technology models. Okay. I don't think there is enough answer to your questions, and Currently I just focus on the requirement of the GDA 7710 and how to extend this model to the other, harmonized with the other technicals, the existing topology model to support streaming. It's like I needed to study together and to position my proposal, harmonize the other document.
Okay, I would suggest that maybe in in the further discussion we can discuss the comparison telemetry and your job and your solution.
Yes, you're right. Yeah. And so the current is what I want to emphasize that this is is the and mainly focused on the device model, not network model, and so it try to minimize the measurement methods to release the burden of the computations, avoid the hardware, something like that. From this point of perspective is I think there's the device model should be different from the network model. That is the current my understanding to the for the GDA 7710 requirement. Okay. Yes. Okay. We can discuss it. This anyway. Thank you.
Yeah, being quick question, I'm probably minor and editorial only. The document refers to G7710, but it's not listed in the references. This is because okay.
Yes, always corrected. Thank you.
Okay. Welcome.
Thank you. I also saw Dan in the queue. Was it by mistake? Dan? On and off. Probably he has microphone issues. Okay, let's move to next presentation. Thanks a lot, Bin.
Thank you.
Shaude, please.
Hi. Oh, okay. Hi everyone, this is Chowder from Huawei. I'm very glad to do this presentation on behalf of the other authors. Next slide, please.
Do you want me to pass the slide control to you, or do you want me to change the slide?
Please help me to control the slide.
Okay.
Thank you. Oh, it seems there's some delay on my side. I'm not okay. And now I can see the second slide.
Yes, we are on.
And this job is about okay, sorry. Okay, this job is about some use cases and definition and requirement draft for ANL4. And before this presentation, I would like to present some notes of this draft. At first, for the motivation of this draft is we want to define some ANL4 use cases and for the transport domain. And also we would like to summarize the requirement for the domain controller. As we know, currently there's a lot of discussion in TMF and ITUT and other SDO, and currently I don't find too many discussion on the ANL4 use case L4 in IETF, and I would like to maybe we need to improve the effort on this part. And for the scope of this draft, and I don't want to provide a very big word in this draft, and I would like to only focus on the use cases description and requirement. And there could be some new interface for L4 use cases. So I would suggest that this kind of young data model can be defined in some other draft instead of this draft. And for the application scenario, and I don't like to distinguish the different networking. And for ANL for I think mostly is about the domain controls requirement, and it is also applicable for the partial disaggregation and also IP pluggable scenario. And currently, we don't have a full list of the ANL for use cases. From my point of view, our authors wills for the ANL for use cases. Currently, we have summarized the service provisioning, automation or adjustment automation, including the wavelength adjustment automation and the OTN service automation and CP plug and play. And also, we would like to focus on the assurance. The service assurance automation can focus on the advantage of a transport domain, such as the latency and the bandwidth and reliability, etc. And also, we like to discuss the transport network CMAP. And actually, currently, there's a lot of digital map of CMAP discussed in IETF, but they are quite generic, and also maybe it is IP specific. For our transport network, I think we also have some requirement for the CMAP. And next slide, please. Sorry, there's some delay. I cannot see the third slide.
No worries, it's coming.
Oh, okay. Okay, now I can see it. For currently, we only have a very rude discussion, and currently we are focused on the service automation. This scenario, this use case is focused on the pain point that the time to market of the service is not guaranteed. The reason for the time to market is cannot be guaranteed is because the OCH trail requires at least 3 weeks work and among multiple departments. And this is figure which we have discussed between the authors. For the service provisioning, you have involved with the planning department and design department and supervisor and some network department. And different department have different work to do. For example, the planning department, they need to work out the assignment book, which is to design the source and destination, and also signal type and the resource constraint. And for the design department, they need to also focus on use to validate the resource, whether it is available or not, and also whether the route is the minimum or optimized options. And for the supervisor, they need to base on the HLD and L on the previous department provided and provide the LD and to provide the service provisioning and do the commissioning. And once there's conflict on this step, and all the previous step will need to be redo again. And then if that is the wider the OCH provisioning take a lot of time. After the OCH have been provisioned and commissioned, and the network department can do the service provisioning on the electronic layer or OTN layer. But all these work are run in serial, so that uh, it takes a lot of time to bring the service to market. So to release this pain point, we consider that there could be some key requirement for this service automation. Firstly, we need to provide optical resource planning and validation, which means that we need to maintenance the planning status and deployment status and in the uh, management system. And the second point is that we need to provide a high reachability assurance, which means that when we do the design, we need to we can do it in multi-layer, and we can design the support to design the parts in different kind of constraint and accompany with the optical parameters. And the third key requirement is that we consider it is need to provide a effective on the resource, and the management system can help to preoccupy the resource and then to avoid the resource to be used by some other service. The third point is that the management system can provide the top-down provisioning approach, which means that when the OTN service provisioning, we can trigger the create a new OSH instead of use the bottom-up approach. We need to create the OSH previous the OTN service. Next slide, please. Sorry, I cannot see the. Okay, for the next step, we will suggest to further discuss the service automation scenario and discuss whether there could be any new model or interface to define. And for the other ANL4 use cases such as CP plug and play and also the transport CMAP, I think could be also the another important part of the work. And we also would like to call for interest and welcome people to join this draft. Okay, thank you. That's all for today's presentation.
Thank you. Thanks a lot. Any question from the floor? So a general comment from my side. I've been working on the TMF autonomous networks a little bit, and I've not seen clean use cases and the requirements on the different areas. If you are speaking about optical, even less. So I think this is for sure some work that is needed. But we need to do this together with the TMF, because this is something that they own, and if they are happy that we build optical specific use cases and requirements, we are definitely more than happy to work on it. But they own the autonomous networks concept. Have you already discussed with someone in TMF about this?
Currently, we have some expert work on TMF, and we would like to invite them to join the discussion after this meeting.
If they...
Okay, thank you, Danny, for the suggestion.
Yep. Okay. Perfect. Thanks a lot, Chodet. Next one. Thomas.
Yeah. Perfect.
Welcome to CCAMP, Thomas.
Yes. Nice to. Thanks a lot for accommodating me in such a short notice. That's great. Can you pass me on the slides?
Absolutely.
Great. Good. So this is an IPFix document, which on behalf of the authors, which we just have published a couple of days ago. It aims for data plane visibility in the passive optical transport area. Specifically, just to give some background, it's about the GPON encapsulation mode, which is defined the architecture in the ITU-T 984.1. So on the right-hand side, you see figure 2 from section 5.2, which gives an overview on the architecture, and I marked red the so-called optical distribution network. So that's the part which connects the OLT from the provider with the ONT at the customer side. And on this ODN, basically this GEM encapsulation is being applied. The GEM encapsulation itself is defined in G84.3. On the right-hand side, you see the figure 811 from section 831, which describes on the top the GEM header and the GEM payload. And the GEM header has actually 4 entries. First, it's the payload length indicator, the PLI. Then we have a port ID and a payload type indicator called PTI. And then a 13-bit header error control at the end, which is called HEC. So the payload length indicator, so PLI, and the header error control HEC are interesting more for the tracing and debugging purposes, so more for the individual frames, and not to get basically like a statistical overview like we can get with IPFix aggregation. Therefore, the IPFix document is just focusing on exposing the port ID and the PTI. First, we need to also look a little bit on the 984.3. There is also a registry which defines the code points for the PTI. So currently we can differentiate between user data and OM data frames, but also whether the frame is at the end or at the beginning. Then here, these are the two IPFix entities, the GEM PTI and the GEM port ID. The GEM PTI would be an unsigned 8 data type with flex semantic, where the GEM port ID would be an unsigned 16 as an identifier. Even though the document was just published a couple of days ago, we already received from the IPFix designated expert at IANA, Paul Aitken, a first review, and we're already discussing with him on the GEM PTI, whether we want to create a registry or not. And here, ideally, what we, let's say from previous IPFix documents, we already discussed is that ideally we want not to recreate the registry which is already existing on the ITU side in the IPFix side, because because if you would do that, if there would be changes on the ITU side, we always need manually to update the IPFix registry as well. So therefore, Paul already reached out at IANA, whether those registry can be synchronized. I'm actually not aware of that ITU has outside of the PDF document a known registry which could be facilitated for that. And here I saw Scott is also in the call, so maybe it would be great maybe here from his side, whether we could facilitate here something, because I think not only for this document but also for future IPFix document, having an automated way of updating the IPFix registries, syncing them with ITU registries, I think that could be helpful. Then just to describe a little bit the use case, here on the right-hand side, you see the OLT, which has upstream to the provider network, for instance, connected through Ethernet, where we have different VLANs, and also we have some so-called quality of service, the priority bit on .1Q with different class selectors or different source bits. And then on the left-hand side, basically each VLAN source bit combination is then mapped to a so-called gem port ID. And from an IPFix data template perspective, a very possible use case is that we have the gem PTI, the gem port ID, together with the source and destination MAC address, the ingress interface and the egress interface with the forwarding status, and that all together gives us visibility into the forwarding status. First of all, whether it's an ORM or a user frame, and whether the packet is being forwarded or not. And from a cardinality point of view, it's accounted for the source or destination MAC address. Yeah, so it's the first revision. We are planning to have an implementation on an OLT and also being verified at one of the next IETF hackathons. I'm looking forward from CCAMP a review on the document. I'm not the optical expert here. I'm coming more from an IPFix side, and we are considering to establish a liaison with the I2T and adoption at Ops AWG. And I see Scott.
Thank you. Scott, please.
We can't hear you. Or at least I cannot.
No, me neither.
Okay.
Maybe not yet. While you're trying to fix your audio issue, maybe we can take Hamian's question.
Hey, hi, Hamian.
Hi, thank you, Hamian from Huawei. Yeah, actually, it's not a question. It's just to adding some more background and my understanding from CCAMP perspective. Actually, it's the first time we talk about the PON technology. And I think one reason behind it is we have good relationship with ITUT Study Group 15, which take care of both transport and access networks. And here it is the kind of IETF protocol extension to a PON network scenario. We don't have too much experience and expertise here, but we do have those one for, say, adapting an IP protocol to optical technology based optical switching based technology. So this is a very important trial for us to evaluate whether we can provide some useful feedback from CCAMP perspective. And I believe given the IPFix, the successful deployment of IPFix on the routers, it is possible to have its adaptation to optical networks, including PON and including other kinds of optical networks like OTN or WDM. So we may have this kind of work in the future.
Cool, thanks. Let's see, Scott.
Okay, can you hear me now?
Perfectly, yes.
Okay, good. Since I think I'm presenting next. But anyway, so on this topic, since I do attend study group 15, and that's one of the areas that this group would be discussed. And I'm also the liaison guy between the IETF and the ITU. If you need help getting the people aligned or finding out where to go or how to interact, just drop me a note and I can help with that. Thanks.
Excellent. Maybe one question, Scott, if I may ask. Are you aware of if ITU has a registry?
If ITU has what?
A registry, like we have at IANA, like an IPFix registry or like a protocol registry. And I was wondering if ITU has something similar.
There are registries that TSB takes care of. I would have to see if there's one for this particular topic or if it's spread out among different documents. So that is a piece of homework I can take based on the information you've provided. So
excellent. Thanks a lot.
Yep.
That would be very much
Yep.
helpful.
Thanks.
Thanks a lot, Thomas. Next one. Is Scott.
Thank you. So did you give me control or are you just going to do it?
As you prefer. Take the control.
Okay, there you go. All right, well, thank you very much for that. And I do have a updated version of this that I'll put a link to in the chat for those. It's very limited. I just found a typo or two. And so let me put that in the chat. I think I put that in the chat, or did I just put that in as a, I don't know what I just did. Where's the chat? Where's the chat? There's the chat. Sorry.
What?
Oh, there we go. Now I got it. I'm just having difficulties navigating operator error completely. That's not a link. Oh, well.
Fix it later.
No. Yeah, exactly. So I'm going to try one more time and then I'm going to give up because I thought I had it in my cut buffer ready to go. There we go. All right. So this should be a short presentation now that I've wasted 2 minutes trying to navigate the system. So we have been working on a Yang data model for microwave radio link. It's as you can tell by the name, it is an abyss of an already existing document. But we've been working on this for probably 2 years now. And since 2019, that's longer than 2 years, isn't it? Well, that's when it was last published, but we started working on this in October of 2023. And what we were trying to do is align it with work that was going on in plug tests in ETSI and make sure that groups like ORAN and others would have a single standard model for microwave radio links. And our goal out of this meeting is, well, since we've been working on it and it's been a team of maybe upwards of 10 people or so have been actively participating in this. And we have a couple of them on the call today. If there's questions, we have Danilo and Italo are on today. I'd like to get to a point where we can ask the chairs to ask for working group adoption. So whatever that process is. So just to give you a few things, we've done some new functionalities based on what you started with in microwave radio link Yang. We've added some functionalities. We did a bunch of cleanup. We created common microwave properties to reduce the duplication throughout the model. So we cleaned the model up a bit. We added some missing configuration parameters, and this is where one of the first missing things is. It says add missing configuration parameter for minimum nominal power. We also did for reference modulation. There's a description on header compression, a definition now for adaptive code modulation, and we're deprecating the way that we used to do radio link terminal mode definition because now we have a new way of doing it that we think is better and covers more of the use cases that are in the microwave area. The current issues that we have a GitHub. So it's private GitHub, but it's a public-private GitHub, if that makes sense. And we also have an issues list. There are several issues that we've gone through, but these are the 6 that are these are the 6 that are important, and that are the ones that we're looking at right now most frequently. And so band and carrier aggregation, things around continuing to fix more information about and covering all the coding modulations, adding a radio signal identifier, and then some other things. Like, for instance, one of the things that I've been doing in other Yang models is looking at RFC 8407 bis, which is it's still not quite done yet, but that is the new version of the Yang guidelines. And there are a lot of really good guidelines in there, especially around security, the security section and other places that we're going to try to adopt some of those things into a future version of this draft. And then so we meet every week, or at least we have meetings scheduled every week. Thursday, 11 to 12 Central European. Now it's summertime, so Central European summertime. And we have minutes. There's the minutes, and then we do a bunch of stuff. And when people write stuff, then we use Git the way Git's supposed to be used. And I guess is that they create some Yang suggestions, do a pull request, and we do the work that way. So that's one of the reasons I would like to move this to working group draft, so that we could get it out of my private GitHub and get it onto a CCAMP GitHub, so we could get more people engaged. And we think it's ready for that next level of conversation. So that's all I had. Thanks.
Thank you. Questions? If none, please, Yang here, the right pronunciation.
Hello.
Hello.
Hi, hello.
Please, go ahead. I use slide controller. Okay. Please go.
No.
No, I do it for you.
Yes, thank you. Thank you.
Okay.
Okay. Okay.
Please, let's go.
Hello, everybody. This is Yanxia from China Unicom. Okay, to next page. Actually, we know the FGOTN in ITUT has been published. So in this work, we present the control interface requirements of FGOTN, and we present 3 scenarios that requires specific consideration, and we define 2 Yang data models for FGOTN topology and FGOTN tunnel. The main changes from the version 1 to 3 is that in this version we further discussed the scenarios present in the draft and made some additional changes. Firstly, we renamed the private 9 service provision scenarios with retrieve service tunnels scenario and modify corresponding content. In these scenarios, what we want to express is that the allocation of TS to support FGOTN switching may be different in access ring and meter ring. And so the service layer ODU may be different. We need to retrieve all the server tunnels, but not just the service provision, so we modified the name and the related description. Similarly, we renamed the service protection scenario with multi-layer path spacing scenario of FGOTN and also modify the corresponding content. Because the actually requirement is to provide the multi-layer path object in tunnel or the LSP. It has low relationship with the protection, so we modify the name. But for this scenarios, the conclusion has not been reached. We found that it's a generic requirement not only for FGOTN, but also for the other layers. We will continue to improve the description of the multi-layer path scenarios in future versions. For the headless resign scenarios of FGTN, we added some more description of interdomain service resizing and modified the figure to contain both intra and interdomain scenarios. For multi-domain resizing scenarios, it's necessary to specify the ODUK-TS and FGTS numbers information on the ports of the cross-domain nodes. Actually, we have established an issue at GitHub to conduct a detailed discussion on the interdomain service resizing. In version 3, we also modify the description of young data model section and further illustrate the relationship with OTN topology and OTN tunnel model. Next slide. Next, I will introduce 3 open issues we have discussed after IETF 121. The first is how to define a generic structure to support multi-layer paths. For this issue, we provide 2 options. One is make a extension on the dependency tunnel structure, and the other one is make an extension on the path element. For the first one, we extension 2 attributes, the index and the working rule under the dependency tunnel. In this example, the 7-layer ODUK for FGTN tunnel from node F1 to F2 is ODU0, and the 7-layer tunnel from node F2 to node F3 is ODU2, and the 7-layer tunnel from node F3 to F4 is ODU1. So the 7-layer ODU layer tunnel for the working for FGTN tunnel will include 2 ODU0 tunnel and 1 ODU2 tunnel. Next page, please. The second option to support the multi-layer path is make an extension on the path element. We can add an underlay tunnel structure under the 3 types of paths depending on the user's requirements. On the right side of the slide, an example of an underlay tunnel message is displayed for root objects of primary path and the secondary path. Next page, please. The second open discussion is how to filter the TPs which support FGTN. The current solution in our draft is argument 1 attribute supported FGTN TP under the termination point to indicate whether the TP can support FGTN. But we don't make agreement on this solution. We provide 2 possible solutions. One possible solution is make some extension on switching capability and encoding, and the another possible solution is defining a new audio type. But both the solutions could have some impact on PCEP and GMPLS protocol. We need to collaborate with Liyi's draft, this draft CCAMP GMPLS capability. Next page, please. This is a young data model of link bandwidth. For the link bandwidth discussing, we have reached agreement on the bandwidth agreement, but the types of FGOTN bandwidth and audio TS number have some different view. For FGOTN bandwidth and audio TS type, it can be a string with Mbps units, or also an integer with representing the number of audio zeros. Next page, please. This is an example of link bandwidth if we choose type string. For example, when the audio interface is 100G, if 16 audio zeros are allocated to support FGOTN switching. For the max link bandwidth, the FGOTN bandwidth is 2000 Mbps. For the unreserved bandwidth, the audio type is audio 0. Audio TS number is 1 to 17, and the FGOTN bandwidth is 20,000 Mbps. Next page, please. For the next step, we will continue the discussion of the previous 3 open issues, including to seek collaboration with the PCEP and the GMPS project experts. And then we will start to discussing the interdomain resizing issues. Through the bi-weekly discussion, we think this work is ready for the working group adoption, and more information can be found on our GitHub. We will also have a bi-weekly meeting on Wednesday, and we welcome other people to join our work. Welcome to contact with us. Okay, that's for the presentation. Thank you.
Thank you. Thanks a lot. I think we are ready to move to the last presentation. Mr. King, did you manage to fix your audio? No. We can't hear you, Dan. It's good that we don't work for telecom companies.
I blame this on the cloud. I don't know if any other author or contributor wants to go through the presentation. Maybe we still have plenty of time, so we can give Dan a couple of minutes to fix his audio issues. If in the no,
can you hear me?
Noise. Yes.
Yeah. Okay. Excellent. I think might be able to see me as well, but hopefully the audio is working now. So sorry for that.
No worries. Now we have high expectations on your presentation. You made us.
Well, I knew the video was working, so it was the next step was interpretive dance, but I'm going to just conserve my bandwidth at the moment. Do I have control of the slides?
Now we do.
Oh, okay, wonderful. So thank you, everyone. Apologies for that. Essentially, this is a relatively recent document. It is our our code document that describes the data models for using Yang in the context of an ACTN network, specifically below the MDSC, to provide rich detail network management. Now, if you were paying attention to some of our previous CCAMP sessions, you would know that there is a companion document, and it's rather kind of long-winded, but essentially it's a framework. Well, it's an architecture that has some elements of a framework, and it describes how we can use various management interfaces, so southbound management interfaces, in the context of an ACTN environment. And specifically, it's kind of evolving ACTN to support some, we originally had fine grain, but we moved on to rich detail. But we could just sort of categorize this as granular network management in order to kind of replicate the kind of functions you might have with FCAPS and other sort of MTOSI Corba type interfaces. So as I kind of mentioned previously, this essentially will reuse our Yang models. It will inherit all of the core functionality that we have with existing CCAMP data models. We will have to identify potentially ancillary models from other working groups, such as TEAS, for instance, and Ivy. But what we want to do is provide fine detailed network management to all of the sort of CCAMP type forwarding equipment. So that could be microwave, it could be electrical photonics, it could be optical electrical, or it could be photonic elements. So that's a variety of CCAMP technology. And this would expose things like topology, performance, inventory, fault alarm, and maybe some security function from beneath the PNC, i.e. the forwarding element. Maybe there's maybe that PNC is a more traditional network management system. Maybe it's a shiny SDN controller. Maybe there's some distributed function as well. Whereas typically ACTN, I suppose the clue is in the name, it's abstracted. What we're doing really is just providing a sort of limited toolkit that would say, well, we don't want the holistic or abstracted view of the network. We actually want to pull out fine detail information about an incident, or about some element of the topology, or about some kind of inventory information. Now, don't panic. The problem that we have here is if we're sort of querying a particular interface, whether it's a physical interface, an electrical, photonic, a software, a socket, an attachment point, there are a variety of naming conventions that we will use. Now, of course, when we're talking about FCAPS, we're typically talking about TMF. So there will be certain object names that are described by the TMF. If we're talking about ITU, sort of G805, 80, 806, etc., then there'll be additional terminology that's described in a variety of those specifications and standards. If it's TAPI, as in the sort of the Linux Foundation TAPI specification, they have their naming information for the elements. Well, even element is, from an IETF or an ACTN perspective, is described as a component. From a TMF perspective, maybe it's equipment. From TAPI, maybe it's element. So what we've had to do for this document is try to harmonize the terminology between all of these sort of different objects across the standards organizations. Now, this sounds like a relatively straightforward task, assuming, of course, that these are well-defined components or elements across each of these standards organizations. And it turns out they are well defined, but they are also not necessarily directly synonymous. There's not necessarily a direct mapping between sort of these different objects. So we're kind of going through an iterative process at the moment, and special thanks to Nigel here and other sort of SDO experts, including Scott, and there are others, and apologies for not sort of name checking you, but you know who you are, so that's good. We're on our sort of third meeting, I think now. These are interim sessions, third or fourth, where we're just kind of talking about the terminology. So what will happen with kind of the future version of this document is that we'll have a really nice set of tables that will show, as we're sort of deploying ACTN-based technologies and we're sort of using some of these CCAMP and other IETF Yang models to provide FCAPS functionality, when we're modeling objects, then if it's a TMF object, our ACTN equivalent is foo. If it's a TAPI object, then it's something else. If it's maybe ITU, and you get the picture. So this is not only sort of Yang code, because we also have the sort of specific RDNM extensions for our sort of Yang higher sort of abstracted tunnel and node and topology Yang models, and we have sort of Yang to describe restoration and locking of resources and scheduling, etc. But we will also need to describe at some point additional functionality. And the point I was trying to make earlier, when it was clear my microphone wasn't working correctly, and this was Bin's presentation, is that of course telemetry is going to be potentially important here, sort of streaming telemetry. So I would expect at some point we'll also, assuming the working group wants to work on Bin's document, that having a Yang model that would show how to subscribe using IETF push and actually provide sort of performance monitoring or maintenance and QoS information from a network element that's being managed by a PNC in the context of ACTN is actually quite important. So the document, just to summarize, will contain this sort of lexicon, Rosetta Stone of terms. It will provide the additional extensions in Yang for providing RDNM functionality. It will have a relatively good list of applicable sort of CCAMP and TEAS Yang models for solving specific examples. So I want to monitor the SLA for an end-to-end connection of what maybe a packet over some Ethernet over WDM or OTN or even some other technology. What are the models that I would use in the context of RDNM while it's being managed by an ACTN-based OSS system? Phew. And then the final slide, I suppose, is there are, like other initiatives we have in CCAMP, there is a GitHub that is tracking the latest version of the document. We have a sort of twice monthly call, and we'll sort of continue to potentially identify gaps that we have with some of the terminology, and maybe come back to the CCAMP list when we have decisions to make. So don't worry, at least for the time being, we're not making any substantive decision in these interim calls. We'll certainly use CCAMP and a normal working group process if we have to make a decision. So Scott, I think you might be the first person.
Thanks, Dan, for this presentation and for pulling this work together. I think this is important work. One question I had, and I probably should know this, but I didn't go look. Are you planning on this slide right here, especially, that shows all the different areas and all the different groups and all the different Yang, are you planning on creating an area in your GitHub where you can have instance examples of how to do this, and then some scripts that run either YangLint or some other tool to show that these do really hang together and the instances make sense when you start looking at them? Thanks.
Yeah, no, that's a really good point. So at the moment, it's kind of a theoretical approach. It would be great to have some automation, and those, from a theoretical perspective, everything is handcrafted. It would be great to be able to compile something and see if it sort of drags through to the sort of the different components. So that's maybe something I can talk to you about. If that's some tooling that would be sort of easy to use, I would gladly have a go and try to use it and integrate that as part of our repository.
Yeah, just let me know when you're ready to start thinking about that or getting close to some decisions on things. I think that would be good. Thanks.
So Daniel, one comment from my side. I think that this work is great. So it's very necessary to have all this relationship on those different concepts and so. But I was wondering also from the other way around. Let's say maybe in some use cases could be we could somehow homologate all or try to escape of all this complexity, considering more or less these different artifacts as the same thing, right? For simplifying the operation. So are also those other use cases of interest for this work, or basically not? Here the point would be just to focus on when we need to differentiate all these artifacts.
Yeah, right now it's really the priority is to show how to use existing IETF models for fine detail network management beneath the MDSC. There will be sort of a variety of use cases that some operators would like to solve. What we'd like to do is reuse and not extend or reinvent beyond what is kind of necessity for the sort of the key use cases, which are things like topology querying, inventory management, some security and performance monitoring. Now telemetry, I think streaming, I think is a really good example. We would probably in the document want to at least have one example or a couple of examples, and maybe we can come back to the working group and sort of find out which one has the most support, and then kind of just at that point just say, right, those are sort of 2 examples or 3 examples. We're now kind of finished. We can show it's applicable, and then looking at maybe in the future, if there were gaps, then it would be kind of separate work. So we're trying to kind of not boil the ocean, but keep things as simple as possible. But the primary motivation was just that sort of operators saying that we want to use ACTN, but we've got existing sort of OSS, which is more sort of mTOSI based or Corba based. How does this fit into the context of ACTN? Do we have to run separate OSS systems?
Okay, clear. Thank you.
Cool. Thanks, guys.
Thank you. Thanks, Dan. So we reached the end of the meeting. I think, personally speaking, this experiment of the interim meetings was really good. If starting from the next meeting, we will restart the meeting regularly during the IETF week. But if anyone feels the need to have an interim meeting on a single document, a bunch of documents, a topic, please let us know, and we will be happy to arrange this and speed the discussion up. That said, Thank you, everyone, and see you in Madrid, if I'm not mistaken. Have a good day.
Thank you.
Hey, thank you.
you.
Bye bye.
Bye.
Thank you. Bye bye.
Thank you. Bye bye.